quickly move on to the next session, that is the keynote address by two eminent academicians who are with us. First I will invite Professor Rajiv Prakash, Director IIT Bhilai, to deliver his keynote address. Professor Rajiv Prakash has been appointed as Director IIT Bhilai by the Honorable President of India. He is a Professor of Material Science and Technology at IIT BHU Varanasi when he was in that capacity. He had held various administrative positions in IIT BHU Varanasi, including Head of Material Science and Technology, Dean R&D and Founder Coordinator of IPR Cell and Central Instrument Facility. He is one of the India's foremost scientists in the fields of electronic polymers, nanocomposites, organic electronics, sensors and energy storage devices. Professor Rajiv Prakash, please.
Thank you very much.
This may sound a little audacious, but I just my humble request to limit your keynote address to 5 minutes. Sir.
5 minutes?
Yes, sir. Thank you very much.
It's not difficult for a teacher. My senior at IIT BHU, Nirban Das Gupta ji, Director in charge, Bhilai Steel Plant. My friend, Professor Ramana Rao, Director NIT. Distinguished colleagues, engineers, academicians, participants from different part of country. Yesterday I also met some of the participants at IIT Bhilai. Thank you very much for coming, for giving this your time for such a wonderful and most important gathering, meeting, conference what we are doing today here. I am also thankful for inviting me, giving this opportunity. Time is less formality, and let us come to topic. IIT Bhilai tending towards net zero campus. Friends, when we are starting something from beginning with some vision, it is easy to do. Today the problem what we are thinking about how to reduce the carbon emission, how to decarbonization achievement and all is because some process is going on, and in between the process we have to change something. I have my own experience when we tried to change some process in compact CD materials in those days when it was difficult to change 10% of the team. When we were using for the packaging film something, it is very difficult because some process is already going on, a lot of inertia to accept the changes. When I am saying that we have to do this decarbonization or we have to opt the green practices, then certainly with some solution, of course. No need to put this slide here when you people are the experts, you are knowing that what is the real problem and what we are going to talk and how to reduce. Friends, I will once again put importance of use of green hydrogen. 1 kg of hydrogen production at present requires nearly 50 kilowatt hour electricity. If you calculate this charge, it will come nearly $3 to $3.5. It is as per the standards what we have calculated based on the European Union meeting 3 years back. Target is to reduce this from $2.5 to $3 to $1.5. As soon as this will come down to $1.5, it will become easy because nearly 50 kg of hydrogen required for 1 ton of steel. So, our colleagues here also said about a lot of the finance part. The money is important, of course, because we are selling something. So, as soon as this will come to 1.5, almost problem is solved. But how to come $1.5 per kg? This is challenge, and this is the again egg and chicken problem. If it is not under use, production will be not there. If the production is not there, the price will not come down. Green hydrogen is not a new topic. Green hydrogen 20-30 years back at IIT BHU and BHU, we did the research on how to use the hydrogen to move the vehicle to take the hydrogen fuel cell and other ways. Hydrogen storage and the hydrogen supply is also not a difficult. These challenges can be also met very easily if you start production of hydrogen. Very much it is required at that place. So the production of hydrogen where it is required. So it will minimize your transportation and storage also. So nowadays it is possible that we can use the green hydrogen production using the various kinds of electrolytes are possible directly at the place or very close to the place where we need the consumption. From a small hydrogen generator to the bigger hydrogen generator, it is possible. So I think in my 5 minutes it will be not calculated. Yeah. Okay, let them do. I'm comfortable. So what is the need of the day? The need of the day is, it's of course, as my colleague said here before me, technology will take time to replace with the new technology, which is the existing technology. Certainly we have to think about the carbon capturing, carbon utilization, decarbonization, but same time let's start the green hydrogen. And IIT Bhilai is committed for this. Friends, we have started talking with the various top group of country as well as abroad, how to produce green hydrogen in a small way and a safe way and utilize it for, especially for the steel making or other processes. In steel making, as you all know, the hydrogen can be used at the two places, one as a fuel and another as a reductant, a reducing material. So at both the places one can use if we have a very good production of hydrogen and supply of hydrogen. So idea with this, which we have already proposed to Bhilai Steel Plant and many other steel industries, that why not we are thinking to start with hydrogen, green hydrogen, with some small units and application. I am not saying at this moment immediately we should target the blast furnace and replacing the some percentage of the hydrogen fuel with the hydrogen. This is also one way, if the 5 to 10% we can replace. But why not with some where you are doing the heating, annealing, post processes, so there why not we can use. My idea is that very soon we are going to have a meeting of small auxiliaries, small units which are functioning in Bhilai and nearby places. Let them talk and why we are not able to provide them a small solution for the hydrogen production and they can use for that process. So total all, if we together are deciding this, that we will start this, friends, price of hydrogen will come down and also this hurdle, this inertia which we are avoiding to not use the hydrogen for our purposes will going to solve. So because the time is not there, otherwise I have planned to present some more projects which we are doing in this direction with you. But hardly matter, subject I try to cover, I can put these slides just at a glance for you people. Thanks to my colleague Professor Soumya Gangopadhyay for giving me this beautiful and nice slides. And of some facilities we have also tried to show. Friends, we are having facilities at IIT Bhilai not very far from this place, and those facilities are ready for use. This before say thank you. So a summary of this talk, that start from a laboratory scale to go to the small scale, pilot scale, and let's plan for the, say, by 2035 when we are expecting, which will get the much lower value of the hydrogen, green hydrogen. So it will come in picture. So this is with this idea, you people are working, you people are expert, you can think more, and as my colleague Professor Soumya Gangopadhyay said, let's have a meeting together and start this as an industry and academia partnership. Thank you very much.
Thank you very much, sir, and we very much appreciate the way you have accorded our request, and provided such a beautiful and informative presentation in a very short schedule of time. Thank you very much, sir.
Thank you.
I now request.
Question I am expecting or no?
Please limit your questions and ask them quickly.
Because in lunchtime I may not be available, so very quick questions, one or two. Yeah,
Sir,
on strategy and planning, please.
Sir, just
not the
one
basic.
data only, sir. How much? What is the cost of hydrogen in the Indian scenario?
You are not audible. Cost of hydrogen you are asking.
Yes, sir.
As I said that in the international market it is 2.5 to 3 dollars.
Dollars is the Indian scenario, sir, because you have conducted
Indian
some pilot.
scenario more or less the same it will be as the hydrogen mission is started. So price will be also more or less the same. And target is, as I said, 1.5 ton.
Thank you.
Sir, you told one figure that 50 kg of hydrogen is required for production of 1 ton of steel. So what incorporation is there? Have you considered only the process or the power? In what way you say that 50?
In a process, actually, this is from the report of the European Union report. They are using this calculation when the iron and from blast furnace coming out. This process, they are calculating 50 kg.
So process what you meant was only iron making process.
Yes.
So not complete steel
No.
conversion.
No. Why they are calculating this? Because the target at present is to reduce this process carbon containing, which is consuming, means creating the problem of 7 to 8% of the total emission of the carbon whole world.
Thanks.
Thank you.
Can I take one question? Sir, thank you so much for, I think this is so interesting, would learn. So my question is, sir, as of now, as a process route, blast furnace, we have POF route is ongoing, and when such a new project comes up, this is a timeline 15-20 years a minimum, and you know as our country it can go to 20-30 years. I see the timeline where you are showing for the hydrogen to be available something around about 20 years or down the line, but you think about how you are anticipating, like how you will bring down the cost, because if users are not there, so you are anticipating for next 10-15 years will continue with the POF route and no new technology will be come to take this hydrogen?
Yeah, very important question. If you see the report, what the Germany is saying. Germany is saying that they are producing the excess electricity and they are capable to use their green energy. They are not only calculating the hydrogen energy but the wind energy and other energies also. So these energy they are capable to utilize for the steel making. See, they are doing this, and no doubt that with the green energy as they have achieved the level, they will do. India is also trying to do. We are also producing, if I am correct, as per the CREDA report, 2 times of our demand. But of course, in this 2 times of our demand, the major part is coming from coal. So, but it is not like this that in coming 5 years, the solar energy and wind energy will come more, and probably we will achieve the 50% of this total production through this green energy. So in this way, when excess of the energy will be there, so that can be utilized for the hydrogen production. What the report of the European Union is saying, you make the electrolyzers production off and on like process. When you have excess energy, you give it to electrolyzer. So in this way, you will minimize the cost of the production. So keeping this in view also, that India is also growing very fast towards the green energy production. So if the green energy production is more, our capacity of production the energy is at present is nearly 2 times. So excess of energies we can also use, which will automatically reduce the price of the hydrogen. Second thing, when it will come in use, no doubt the production will go down. Electrolyzer cost is at this moment is quite high. So electrolyzer cost will come down. So my request was to this at this moment to not think to replace the energy process of furnaces directly, but let us start from the small scale where we can do. Means it should come more in practice at this moment, and then certainly from practice to becoming the pilot level and to going further will be easy, as I am looking forward the reduction of the price of the hydrogen also in coming next to 5 to 10 years.
have done some experiments also, and I offer you this blast furnace for your any experiment you want to do.
We have applied for a big project for hydrogen one, and I am quite optimistic that IIT Bhilai will get this project. And even if the project is not coming to us, thank you very much. And we are looking for some small such type of furnaces, other test furnaces where we can use. But apart from this, my request is again, small industries and auxiliaries companies, small units around this Bhilai Steel Plant in Bhilai, they should come forward and let us see that how we can reduce the consumption of coal there. So it will be also a great initiative through them to reduce this carbon, though it will be not very significant. But at this moment, my whole worry is to bring this in practice. Certainly, there will be an issue of challenge for the money, whether the cost, but that can be addressed easily. I think we will find out some way. Thank you very much.
Thank you, sir.
Since we are running short of time, no more questions, please. Thank you, sir.
Hello. I now invite Dr. N.V. Ramana Rao, Director, National Institute of Technology, Raipur, for his keynote address. A brief introduction about him. Sir carries more than 3 decades of rich experience in teaching, research and consultancy in the field of civil and structural engineering. He has authored 5 books on topics related to civil and structural engineering and is a well-known subject matter expert. His consultancy spans high-rise structures, construction of bridges, flyovers, roadways, non-destructive testing.
But I don't want to play the slides. This presentation is available for circulation among the participants. Just to save time, for 2 reasons. One, I am a civil engineer, so I don't have much idea about metallurgy and materials. But yes, as an engineer, we are definitely issues related to decarbonization and infrastructure development. So we know that the steel industry plays a critical role in global infrastructure construction, automotive manufacturing and various other sectors. This will span airports, stadiums and high-rise buildings. So first issue is regarding climate change mitigation and reducing the carbon footprint, and therefore decarbonization is essential for reducing the steel industry's carbon footprint. So the need is to transition to low carbon economy. Steel producers, as just the discussion that was happening, we came to know, are under pressure to transition to low carbon production methods to meet national and international targets. So this requires a lot of innovation and competitiveness. In the morning somebody was talking about green steel. So development of green steel, which is produced from significantly low or zero carbon emissions, is an area of innovation. A lot of research is going on in various industries and institutions. So the companies that lead to producing green steel can gain a competitive advantage as demand for sustainable products increases. And then there is a need for new technologies, as just Professor Rajiv Prakash was mentioning. So decarbonization drives the adoption of new technologies such as hydrogen-based direct reduction, carbon capture and storage (CCS), and the use of renewable energy sources in steel making. Not only that, the issue of decarbonization will require regulatory compliance and meeting regulations. The governments worldwide are implementing stricter regulations on emissions, and steel companies must comply to avoid penalties and remain in operation. And there is something called as carbon pricing mechanisms, such as carbon pricing and emissions. Trading systems are becoming more common, making decarbonization economically advantageous. Then we also have investor and consumer pressure. There is another issue for sustainable investment. So investors are increasingly focusing on environmental, social and governance (ESG) criteria. Companies that do not address their carbon emissions may face divestment or reduced access to capital. And then consumer demand is a growing demand, growing consumer preference for products made with environmentally sustainable methods, including steel. Coming to the role of infrastructure development in steel industry, everything is demand driven and urbanization and growth is a factor. So infrastructure development, particularly in emerging economies, drives demand for steel in construction, transportation and utilities. Then we have public and private investments coming into the infrastructure. the government infrastructure initiatives, especially the recent initiatives announced by the Government of India, in such as focus areas of transportation, energy and urban development, significantly contribute to the steel industry's growth. Then product innovation such as high strength steel. So there is a need for more durable, lighter and more efficient materials for infrastructure projects, encourages innovation in steel products such as high strength, low alloy and HSLA steel. Sustainable infrastructure, there is a growing emphasis on sustainable infrastructure, which includes the use of recycled steel, especially from the scrap, and the incorporation of energy efficient and environmentally friendly materials. Then also when we talk about infrastructure, it talks about economic growth and employment, job creation. So infrastructure projects create significant employment opportunities both directly in the construction and indirectly in the steel industry, supporting economic growth. Then we have economic multiplier effect. Investment in infrastructure has a multiplier effect on the economy, stimulating demand in various sectors including steel. Then we are talking about circular economy, recycling. So infrastructure development definitely contributes to a circular economy by promoting the recycling of steel from old structures, from scrap, reducing the need for raw materials, extraction and lowering carbon emissions. So I would like to conclude my presentation. The decarbonization and infrastructure development are interlinked and pivotal for the future of the steel industry. While decarbonization addresses the urgent need to mitigate climate change and aligns with global sustainability goals, infrastructure development continues to drive the demand for steel, fostering innovation and economic growth. The successful integration of decarbonization strategies with the ongoing expansion of infrastructure is crucial for ensuring the long-term viability and sustainability of steel. So with these brief remarks on the issues and concerns, I would like to thank the organizers for giving me. Thank you very much.
Thank you very much, sir. The house is now open for questions. With the paucity of time,
Question should be only on the infrastructure because I am only a civil engineering expert. I don't
Absolutely,
let
sir.
me admit.
we'll ensure that. And owing to paucity of time, I request our audience to please limit the questions to 3 only. Thank you.
Thank you.
Any questions, please?
Thank you very much.
Thank you, sir.